Welcome to the session on factors and greatest common factors. In our last lesson, we learnt about factors and factor trees. Today, we will review these ideas and then learn how to find the greatest common factor of two numbers. So by the end of the lesson, students will be able to find factors of a given number, use a factor tree, identify common factors, and find the greatest common factor. So let's review factors and factor trees before extending these ideas. Now let's take a look at factors. What is a factor? Factors are numbers that divide exactly into another number. So consider the number 6. 6 divided by 1 equals 6. 6 divided by 2 equals 3. 6 divided by 3 equals 2. And 6 divided by 6 equals 1. Therefore, the factors of 6 are 1, 2, 3, and 6. Factors divide exactly into a number. So, for example, if we have 12 divided by 3, we obtain 4. In other words, 3 is a factor of 12. However, 13 divided by 5 equals 2 with remainder 3, which means that 5 is not a factor of 13. A factor tree helps us break a number into smaller factors. So, for example, if we look at the number 24, we can begin by noticing that 24 equals 4 times 6. And then we can continue splitting until all the branches end with prime numbers. So, 4 is equal to 2 times 2. Both of these numbers are prime. And 6 is equal to 2 times 3. And both of these numbers are also prime. So therefore, 24 expressed as a product of prime factors is 2 times 2 times 2 times 3, as shown here. What about if we start differently? In the previous slide, we expressed 24 first as 4 times 6. However, say if we hadn't spotted that and we started with 3 times 8, like so. Now let's see what we get if we split further. 3 is already a prime number, so we can't split that branch further. However, 8 can be split further, and you might notice that 8 equals 2 times 4. So let's take a look. Can we split either of these branches further? 2 is a prime number, so therefore we can't split that branch. However, 4 can be split as 2 times 2, as shown here. So we started differently, but let's see what happens. 24 equals 3 times 2 times 2 times 2. So we did start differently, but we ended with exactly the same prime factors. What about if we start differently? Say with 12 times 2. So 24 equals 12 times 2. We continue splitting until all branches end with prime numbers. 12 equals 2 times 6, and 6 equals 2 times 3. Now that all the branches end with prime numbers, we can express 24 as a product of prime numbers. So we have that 24 equals 2 times 2 times 3 times 2. So no matter which factor tree we use, the prime factorization is always the same. All of these trees produce 24 equals 2 times 2 times 2 times 3. For this tree, and this one, and this one. Recall that factor pairs multiply together to make the number. We can find factors by listing all factor pairs. So for the number 18, we can express 18 as 1 times 18, or as 2 times 9, or as 3 times 6. So the factors of 18 are 1, 2, 3, and 6, 9, and 18, as shown here. Let's take a look at another example. 20 can be expressed as 1 times 20, or 2 times 10, or 4 times 5. So the factors of 20 are 1, 2, 4, and 5, 10, 20, as shown here. Now let's list all the factor pairs of 12 in order to find the factors of 12. So 12 can be expressed as 1 times 12, 2 times 6, and 3 times 4. Therefore, the factors of 12 are 1, 2, 3, and 4, 6, and 12. We're now going to take a look at common factors and greatest common factors. Let's take a look at an example to illustrate the idea behind common factors. The factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 18 are 1, 2, 3, 6, 9, and 18. The common factors are therefore 1, 2, 3, and 6. These are called common factors because they belong to both numbers. The greatest common factor is the largest factor shared by both numbers. So in this case, it's the number 6. And therefore we have that the greatest common factor of 12 and 18 is equal to 6. Now let's take a look at the greatest common factor of 8 and 12. The factors of 8 are 1, 2, 4, and 8. And the factors of 12 are 1, 2, 3, 4, 6, and 12. The common factors are 1, 2, and 4. Therefore, the greatest common factor is the largest of these, and that's the number 4. Let's now find the greatest common factor of 15 and 20. So the factors of 15 are 1, 3, 5, and 15. And the factors of 20 are 1, 2, 4, 5, 10, and 20. Therefore, the common factors are 1 and 5. Therefore, the greatest common factor is the largest of these, which is equal to 5. We can also find the greatest common factor using factor trees. So remember that 36 can be expressed as 4 times 9, and 4 can be expressed as 2 times 2, and 9 can be expressed as 3 times 3. And remember that 24 can be expressed as 12 times 2, and then as 2 times 6, and 2 times 3. So 36, remember, equals 2 times 2 times 3 times 3. And 24 equals 2 times 2 times 3 times 2. The common factors are 2, 2, and 3. Therefore, the greatest common factor is equal to 2 times 2 times 3, which is equal to 12. Today we learned how to find factors, identify common factors, and calculate the greatest common factor. In particular, We learnt that factors divide exactly into a number, factor pairs help find factors, different factor trees give the same prime factorization, common factors belong to two or more numbers, and the greatest common factor is the largest common factor and is also represented by the initials GCF. Now pause the video and have a go at these exercises. Press play when you're ready to view the solutions. Solutions are coming up shortly. This brings us to the end of this session. Do attempt the exercises in your textbook related to this topic. Thank you very much for listening.